Hi, this is the Science Chef. In this video, I'll be showing you how to answer the likely volumetric analysis questions you might encounter in the 2023 WAEC Chemistry Practical Alternative B. Before we continue, if you like what we've been doing in this channel and you're yet to subscribe, kindly hit the subscribe button and turn on your notification bell. Don't forget to drop your comment and also like this video. Alright, let's start. Question 1. You're told that E is a solution containing 2.97 grams of HX in 1 dm cube of solution. F is a solution containing 0.0800 moles per dm cube of sodium hydroxide. Put E in a burette and titrate with 20.0 cm cube or 25.0 cm cube of F using methyl orange as indicator, blah blah blah. From your results and information provided, calculate the 1. Concentration of E in moles per dm cube, 2. Molar mass of HX, 3. Relative atomic mass of X, 4. The mass of the salt produced during the titration. The equation for the reaction is as shown on the screen. The volumetric analysis for alternative B is also an acid-base titration, but unlike alternative A, where the acid and base were labeled A and B respectively, in alternative B, it will be labeled E and F. In your solutions in the exam hall, don't make the mistake of using A and B as your acid and base, right? Stick to the label that's given in the instruction, which is what? E and F, right? I just said I should bring that to your notice. So let's move. So what are we given? We are given, I always love to divide my screen. Let me divide this first before I continue. We are given concentration of E in grams per dm cube to be 2.97 grams per dm cube. They are also given the concentration of F in mole per dm cube, that's the molar concentration, to be 0.0800 mole per dm cube. Then we are given the volume of acid used, is your Titre value, that's VE is about 24.57, the theoretical value anyway, but make sure you work with what your teacher gives you. While the volume of base is always the volume of the pipette, in this case is VF, that's 25.00 cm cube. So we are told to calculate concentration of E in moles per dm cube. So 1. Concentration of E in moles per dm cube, that's molar concentration of E. To calculate molar concentration of E, you can use concentration in grams per dm cube divided by molar mass. But do we know the molar mass of E? No, you don't know. Why? Because the equation of reaction is HX plus NaOH equals to, or gives us what? NaX plus H2O. Since we don't know the value of X, we cannot determine its molar mass, so we cannot use concentration in grams per dm cube divided by molar mass. So in that case, we are going to use our cover. So using CEVE over CFVF equals to NE over NF, which is equals to 1:1. Please always remember to write this mole ratio, right? The value, yes. So, and what are we looking for? You're looking for CE, right? CE, which is in concentration of E in moles per dm cube. So our CE, make it subject of formula, we equal to CFVF times 1 all over VE times 1. So you substitute the values for CF and VF. CF is concentration of F in moles per dm cube, that's 0.0800 times volume of base, VF is 25, then times 1 all over volume of acid, VE, that's 24.57, then times 1. This will give us 0.0814 mole per dm cube, your calculated concentration values must always be in 3 significant figures, and don't forget to add your unit. Okay, that's one. So the next item you're asked to find is molar mass of HX. Good. I told you that since we did not know the value of X, there's no way you can calculate the molar mass from its relative atomic masses. So you have to use another formula, which is what we are going to use now. So 2 molar mass of HX, we are going to use the formula concentration of HX, which is our E, in grams per dm cube divided by concentration of HX in moles per dm cube. So if we substitute the values here, our concentration in grams per dm cube is 2.97. That's 2.97 divided by concentration in moles per dm cube is 0.0814. So if we evaluate that, that will give us 36.48, let's say 49.49 grams per mole. So don't forget to add your unit when calculating your molar mass, right? Grams per mole. Good. So 36.49 grams per mole. All right. The next question you're told to calculate the relative atomic mass of X. Good. Question 3, you're told to determine the relative atomic mass of X. Now to get the relative atomic mass of X, now that's what AR of X. We're going to use molar mass of X equals to AR of hydrogen plus AR of X, right? So molar mass of X that we calculated is 36.49 grams, right, per mole, not necessary. So an AR of hydrogen is 1 plus AR of X. So AR of X here will be equal to 36.49 minus 1, which gives us what? 35.49. This is approximately 35.5, right? Remember, relative atomic mass has no unit. Now, which element has a relative atomic mass of 35.5? Your guess is as good as mine, right? That's chlorine. Alright, it means that the acid is what? Hydrochloric acid. Alright, and the last item for number 1, you're told to calculate the mass of salt produced during titration. During the titration. Okay, so from the equation of reaction that we had, is HX plus NaOH giving us NaX, the balance equation, plus H2O. So now that we know the value of X, that's HCl plus NaOH giving us NaCl plus H2O, right? So that from the equation of reaction, 1 mole of NaOH produces what? 1 mole of NaCl, right? Or NaX, whichever one. So how do you calculate number of moles of sodium hydroxide here? Number of moles of sodium hydroxide involved in the titration will be equal to what? Concentration of sodium hydroxide times volume of sodium hydroxide in moles per in dm cube, right? So that would be, that's volume of sodium hydroxide in dm cube. So, and the concentration of sodium hydroxide used in the titration is 0.0800 mole per dm cube, while the volume of sodium hydroxide used in the titration is 25 cm cube. So in terms of in dm cube, that would be 0.025, that's divided by 1000 dm cubes. So if we calculate this will give us that that will give us 0.002 mole. So if 1 mole of sodium hydroxide gave us 1 mole of sodium chloride, it implies that 0.002 mole of sodium hydroxide will also give us what? 0.002 mole of NaCl, right? So now mass of NaCl produced Now, this 0.002 mole NaCl is the number of moles of the salt that was produced during the titration, because NaCl is the salt, right? So since we are using the volume of the base that was involved in the titration to get it, that gives us the number of moles of the salt that was produced during the titration. And we are going to use that number of moles to calculate the mass. And the mass here is given as number of moles of NaCl times molar mass. Times molar mass of NaCl. So that will give us 0.002 times NaCl, that's 23 plus 35.5, that's 58.5. That's 0.002 times 58.5, which gives us what? It gives us 0.117 grams of NaCl. So which means that 0.117 grams of NaCl was produced during the titration. So that is that on question 1. So we move to question 2. Question 2. E is a solution containing 0.100 mole per dm cube HCl. F is a solution containing 6 grams per dm cube of impure sodium hydroxide. Put E in a burette and titrate against 20.0 cm cube or 25.0 cm cube of F using methyl orange as indicator. From the results and information provided, calculate the 1. Concentration of F in moles per dm cube. 2. Concentration of F in grams per dm cube. 3. Percentage impurity of the impure sodium hydroxide. 4. Volume of solution E that will neutralize a solution containing 0.005 mole of sodium hydroxide. I also added 2 more questions that, well, they might ask. There's no harm in knowing this, right? You're told to state the color of a naphthalene indicator in solution F. Solution F is the base, right? Then state why methyl orange is a suitable indicator for this reaction. And of course, we have the equation of reaction as shown on the screen. Okay. So solution, right? Then what are we given? So always go to write out what you are given so that to guide you in solving the question. From question 2, we are given the concentration of E in moles per dm cube. That's your CE, which is 0.100 mole per dm cube. This is based on the question. You can be given any concentration in the question, it doesn't matter what the most important thing is understanding the principle, right? Then the mass concentration of impure, that's concentration of impure sodium hydroxide. And whenever you see a question like this, then expect something on percentage purity or percentage impurity. So this 6.0 grams per dm cube. Whenever you have a question like, don't ever use this concentration of impure sodium hydroxide or the impure substance to calculate the concentration of the pure substance in moles per dm cube or the molar mass of the pure substance. Don't ever use it, right? That would be a mistake. Then volume of E, acid used. Volume of acid used, that's VE, we'll stick with a 24.57 cm cube. Then volume of base, that's our VF, that's pipette, will be 25.00 cm cube. Okay, let's write the equation of reaction. That will be sodium hydroxide plus HCl, giving us what? Sodium chloride plus water. Okay, question 1. What are we told to find here? In question 1, item 1, we are told to calculate the concentration of F in moles per dm cube. You see, these guys are very tricky. That's the first thing you are being asked to calculate. They want you to use this concentration of impure sodium hydroxide to calculate the concentration of F in moles per dm cube. Try that, you are a gunner. So you're not going to use this, rather you're going to use a CAVA, right? So, but in this case, it's going to be CEVE over CF VF equals to what? NE over NF is equal to 1 over 1. Always write the mole ratio out. Then next thing is to make what you're looking for subject of formula, which is in this case is concentration of what? FCF. So you make CF subject of formula here, which is CE VE times 1 all over VF times 1. Please don't jump any step, just follow the steps the way you are being shown on the screen. So then we substitute here. Our C is 0.100, our V is what? 24.57 cm cube, of course, times 1 all over VF is 25 times 1. So that gives us what? That gives us 0.09828 mole per dm cube. But remember, your answers must be in 3 significant figures, so it gives us 0.0983 mole per dm cube. Great. So we are done with that. You earn your 4 marks there, cheap 4 marks. So move on to the next question. Next question is concentration of F in grams per dm cube. Can you see? That's to tell you that you were not expected to use that concentration in grams per dm cube of the impure sodium hydroxide in any calculation yet, except when you want to determine the percentage purity, right? So from here, since we know the concentration of F in moles per dm cube, and we know what F is sodium hydroxide, even though it's impure, at least we know the pure form of which is sodium hydroxide, we can calculate its molar mass. So we are going to use concentration of F of sodium hydroxide in moles per dm cube times molar mass of sodium hydroxide. What's the calculated value of concentration of sodium hydroxide in moles per dm cube that we got? That's 0.0983 times what's the molar mass of sodium hydroxide? That's 23 plus 16 plus 1. Always show how you get your molar mass. That's 0.0983 times, that will give us 40, if I'm not mistaken. So this gives us 3.932. Remember, the unit of this is in grams per dm cube, but your value must be in 3 significant figures. So this will be what? Approximately 3.93 grams per dm cube in 3 SF. Alright, you're making progress. Go on to the next question. Next question says percentage impurity of the impure. I tell you, whenever you see a question like this, expect percentage impurity or percentage purity. So percentage impurity of impure sodium hydroxide will be calculated as concentration of impure minus concentration of pure all over concentration of impure, all in grams per dm cube. right, times 100 over 1 times 100 over 1. So everything here is in grams per dm cube, grams per dm cube, grams per dm cube, right? Grams per dm cube, grams per dm cube. Good. So this will be what's the value? 6.0 minus 3.93. 6.00 minus 3.93 all over 6.00 times 100 over 1. This will give us, remember, you're not looking for percentage purity, you're looking for percentage impurity. So be very, very careful here. So 2.07 is the amount of impurity that was present. So this over the total mass times 100 over 1 will give us the percentage impurity, which is 34.5%. Right? Good. And the next question says, in the next question we're asked to calculate the volume of solution E needed to neutralize a solution containing 0.005 mole of sodium hydroxide. Okay, so from the mole ratio, number of moles of E is HCl to number of moles of sodium hydroxide is 1:1, right? 1 mole of HCl gives us 1 mole of sodium hydroxide, right? So what amount of HCl will react with 0.005 mole of sodium hydroxide? Therefore 0.005 mole of HCl will also react to 0.005 mole of sodium hydroxide, right? Good. So now we have to find the volume of solution E, and to find the volume of solution E we are going to use the relationship between number of moles, concentration, and volume. But number of moles of HCl equals to concentration of HCl times volume of HCl in dm cube, right? In dm cube, that's volume of solution E, since solution is HCl. And what's the concentration of HCl that was given to us in the question here? 0.1. So from here you can see that our volume of HCl, which is what we are looking for, will be equal to number of moles of HCl divided by concentration of HCl in moles per dm cube, and that will be 0.005 mole divided by 0.1 mole per dm cube. 0.1 mole per dm cube. So if we evaluate this, find out that the volume of HCl, or solution E, that would neutralize a solution containing 0.005 mole of sodium hydroxide is 0.05 dm cube, which is equal to 50 cm cube, right? 50 cm, because if you convert dm cube to cm, you multiply by 1000, that gives us 50 cm cube. All right, so the next question here, these are the bonus questions now. State the color of phenolphthalein indicator in solution F. Solution F is a base, like I told you, so it's an alkaline medium. So, and the color of phenolphthalein in an alkaline medium is pink. In acidic medium it is colorless, while in neutral medium it is also colorless or pale pink, but they accept colorless, right? So since you ask for solution F, which is an alkaline medium, then the answer is what? Pink or purple. Let's go with pink. So 5, color of phenolphthalein in solution F is pink. Good. Last question, we asked to state why methyl orange is a suitable indicator for this reaction. Methyl orange is a suitable indicator for this reaction because it is a strong acid, strong base titration. Methyl orange is most suitable for titrations that involve strong acids, right? Because it changes its color within the acidic region. But since the strong acid, strong base is suitable as an indicator for the titration. Actually, for strong acid, strong base, any indicator can be used. Methyl orange, phenolphthalein, and litmus are all suitable for strong acid, strong base titration, right? But if it were a weak acid, strong base titration, then phenolphthalein would be the most suitable. So that brings us to the end of this tutorial. If you had learned anything, subscribe to this channel if this is your first time here. And if you had forgotten to like this video, you can quickly do so now, and don't forget to drop your comment, right? Endeavor to turn on your notification bell to always stay updated with our new uploads, right? Keep doing what you know how to do best until I come your way next time. God bless you.